Today we are discussing with this 7 crystal lattice. We know that the three-dimensional space lattice is generated by repeated translations of three non-coplanar vector A, B, C based on the lattice parameters. We can have 7 popular crystal systems. Bravais lattice. In 1850, M.A. Bravais showed that identical points can be arranged spatially to produce the 14 types of regular pattern. These 14 space lattice are known as the Bravais lattice. Each point in a lattice is called lattice point or lattice site. Each point in a crystal lattice represents one constituent particle, which may be an atom, a molecule, group of atoms, or an ion. The lattice points are joined by straight line to bring out the geometry of the lattice. So Bravais lattice in 1815, Augustine's Bravais is founded on this identical particle can be arranged as other 14 types of regular patterns who founded on this Augustus Bravais. So this is each point in a lattice is called a lattice point or lattice sites. Unit cell. Unit cell is the smallest portion of the crystal system, which when repeated in different directions generated the entire lattice. It is characterized by its dimensions along the three edges A, B, C. These edges may or may not be mutual perpendicular. The angles between the edges alpha between B and C, beta between A and C, and gamma between A and B. Thus, a unit cell is characterized by 6 parameters. In a crystallography, the terms crystal system, crystal families, and the lattice systems each refer to one of the several classes of space groups and lattice points groups and crystal. Informally, two crystals are in the same crystal system if they have similar symmetries, although there are many exceptions to this series. The units are alpha, beta, and A, B, and C. Similarly, these different angles. A unit cell is the smallest portion of the crystal lattice that show the three-dimensional pattern of the entire crystal. A crystal can be as the same unit cell. So this is a cubic structure as a part of that A, B, and C, and alpha, beta, gamma. The different sections. The unit cell are repeated over and over in 3 dimensions. Primitive and centered unit cell. Unit cell can be broadly divided into 2 categories: primitive and centered unit cell. When constituent particles are represented only on the corner position of the unit cell, it is called a primitive unit cell. So this is when broadly divided into 2 categories: primitive and centered unit cells. When a unit cell contained one or more constituent particles present at the position other than the corner in addition to those at corner, so different corners, to be called center unit cell. Primitive unit cell, a unit cell which has only one lattice point in a crystal. The center unit cell, if the constituent particles of a crystal lattice are presented at position other than the corner. So this is a main important, other than the corner. It is addition to those that are at corner. If it is known as the center unit cell. So mainly is a constituent particles of the crystal lattice are present at those positions other than the corner. In addition to those the corners, it is known as the center unit cell. Three types of centered unit cell. Three types of centered unit cells. The body center unit cell. Such a unit cell contains one constituent particles, atom, molecules, or ions. It is a body center. Beside the ones that they are at the corner. The body center. See that this body center of this cubic structures. The center unit cell. Face center unit cell. Such a unit cell contains a constituent particles present at the center of each faces. See that this the FCC structures and different faces. How many faces in this cube? 6 faces. Okay. Such a unit cell contains one constituent particle present at the center of each faces. Beside this, one that it is corner. In corner there is a face center unit cell. FCC means face centered cubic is the name given the type of atoms arranged found in nature as face centered cubic unit cell structures consist of atoms arranged in a cube where each corner, so different angles, different area, each corner the cube has a fraction of atom with the 6 additional full atom positioned at the center of the each cube faces. So end centered unit cell. In such a unit cell, one constituent particle is present at the center of two opposite faces, up and down. Upsides, beside the one present its corners. See that the cubic of one atom each placed one on two opposite faces of the cube. Thus we can say that is 8 atoms are present at 8 corners. See that each atom will be contribute into post 2 into 12 is equal to 1 atom. Therefore total number of atom is 2. 14 Bravais lattice cubic structure. Primitive or simple body center. See that this the corner of this atoms and then the center of this face center, this body center and face center. A is equal to B is equal to C, alpha is equal to beta is equal to gamma is equal to 90-degree angles. The corresponding examples of these crystals in cube structure, NaCl, sodium chloride, zinc, lead and copper. This is a cubic cube. Second one is a tetragonal, square prism. Already we are seeing that cubic. This is a square prism of general height. See that this is a primitive first one, and another one is a body center. A is equal to B is not equal to C. Alpha is equal to beta is equal to gamma is equal to 90-degree. With the example of this crystal is tin titanium oxide. So many examples for this tetragonal of square prism. Another one is here. Third one is here. Orthorhombic rectangular prism general heights. First one, see that the primitive simple structure. Another is a body center. Another is a face center and the end center. See that is different corner of the atoms and the center of and body center, face center, and in the center is A is equal not equal to B is not equal to C. So there's another one example is alpha beta gamma is equal to 90-degree angle. So this is a orthorhombic the rectangular prism is this general heights. Okay. Their example is potassium nitrate. Another one is barium sulfate. Monoclinic, another one is monoclinic parallelographic prism. Parallelographic prism. See that the primitive or simple cubic. See that this monoclinic structures more than 90-degree and less than 90-degree. See that this picture A is not equal to B is not equal to C. This is already we have discussed the end center. So this is ups and the opposite two opposites the face center corner. For example is sodium sulfate. Sodium sulfate decahydrate. See that this hexagonal 120-degree rhombic prism. The rhombic prisms are used to displace a beam laterally without changing its directions. They may be coated to transmit part of the beam and produce two parallel and displaced emerging the beam. These prisms, so actually, for example in zinc oxide. Another one is cadmium sulfate. See that this face of this rhombic prism in hexagonal. A is equal to B is not equal to C. Alpha beta is see directional of this parallel of the diagram. So alpha beta is 90-degree and gamma is 120-degree. A B C this see this angle and A part to B the direction of this angle is 120-degree. A and C is 90-degree. So alpha beta is 90-degree and gamma is 120-degree. See that the crystal systems are defined based on symmetries, rotational, mirror, and inversions, etc. Those is forming the points groups and not on the geometry of the unit cell. Remain this point in note it. Bravais lattice refer to this 14 different three-dimensional configuration into which atoms can be arranged in a crystal. Thus, a Bravais lattice can refer to the one of the 14 different types of unit cells that the crystal structures can be made up of the So 14 different types of unit cells, crystal structures. These are lattices are named as the French scientist in Lattice Bravais. The crystal lattice system is a hexagonal. We already discussed is a hexagonal. M is a monoclinic, orthorhombic, tetragonal. So is a hexagonal is a D6, monoclinic is a C2, orthorhombic is a D2, and the tetragonal is a T4. So this is a Bravais lattice. 14 possible crystal structures with illustrations. Thank you.